So any angle here is just going to give you a triangle to the x-axis in one of the quadrants. That's all you have to understand. That is how we define angles, okay? Now you may be asking yourself, so why in the world is this topic called the unit circle? Well, as someone's probably told you, it's the unit circle because this hypotenuse here of the triangle always is going to be 1. No matter where you put your triangle in the unit circle, the hypotenuse is always 1. But why is this important? Why does it have to be 1? Because allow me to remind you, okay, and this is where things often get very confusing in school, that what we said at the beginning was similar triangles have the same ratio. In other words, it doesn't matter how big your triangles are, you're still going to get the same cosine, sine, and tan, right? The size of the triangle does not determine the values of cosine, sine, and tan. The only thing that determines that is the angle. So why are we concerned with this word unit? Why is it supposed to be the unit circle? The answer is it helps us, it's like a crutch, it helps us visualize better. It doesn't actually change anything about the values. And this is often missed in school. So let's think, what is cosine of this triangle in the unit circle where the hypotenuse is 1? And now let's call this side the x side, and let's call this side the y side, okay? And you can make a big thing about how that's the point, but let's not even get into that. It's not even necessary. The only thing you need to understand is this side is x, that side is y. So in this case, the cosine would be adjacent over hypotenuse, or x over 1, which is equal to x. So when the hypotenuse is 1, this length here is actually cosine. That is the whole reason that we choose the unit circle. Now, if we were to make the circle bigger, that wouldn't change the value of cosine. It would still be the same value, but if the circle was bigger, let's just make a bigger circle here, then let's say this is 10, okay? Obviously it's not to scale. Then this length here would actually be 10 times the cosine of the angle or something. The ratios are still the same because when you divide, you still get cosine. The only reason that the unit circle is useful is because this length in the unit circle happens to be exactly cosine. And the same thing is true for sine, right? Sine is going to be opposite over adjacent, or just this y length. So once again, the whole reason that the unit circle is useful is because it helps us actually visualize this just a tiny bit easier. Instead of thinking all of these things are multiples or something, this is actually cosine. This is actually sine, okay, in the unit circle. Why am I telling you this? Because if you understand this, if this is really clear to you, that in the unit circle, this is cosine and this is sine, right? So this side is cosine and this side here is sine, okay? If that is clear to you, then everything else falls magically into place. And you don't have to memorize anything. We're trying to define, for instance, cosine of an angle bigger than 90, because up until now, all we knew how to do was cosine and sine and stuff of angles that were in between 0 and 90, right? What we really mean is the triangle to the x-axis, and then we just have to figure out that angle. So if this is 110, then that angle is going to be 70 because those two things add up to 180, right? Now, what is it that we mean when we say cosine of that angle? Well, all we mean is cosine of this triangle, right? So really what we mean is cosine of 70. That is the gist of this, which you may be asking yourself, so then why are we even doing all this? This is unnecessary. Well, there's one little thing that happens, which is, remember what I just said, cosine is the x side of the triangle. Now that just helps us visualize the fact that this is exactly cosine. Well, if that is cosine, then cosine has to be negative here because it's on the negative x-axis. That is the last part of this definition. And once you understand that, you're basically done. You have to understand how to define the angle, which we did. And now all you have to do is understand that when I have a cosine and it's over here where the x is in the negative, then it's going to give me the same answer as I would for this angle except with a negative. In other words, cosine of 110 is equal to the cosine of this triangle, which is 70. And then you just have to say, hey, look, the x over here is going to be negative. There's nothing more to this whole topic. Okay, I admit that those two things are a little confusing, how to define the angle and now thinking about the negative. But that's it. Once you understand that, there's nothing else to memorize, nothing else to understand. So, what about if I said sine of 110? Well, I would once again be referring to the same triangle with 70. Now all I have to do is think about, okay, I know it's going to be the same number as sine 70 because it's that triangle. Now all you have to do is think, hey, is it going to be plus? Is it going to be negative? Is it going to be positive? And then you just remember that sine is always the y part of the triangle, and is the y positive or negative over here? And the answer is it's positive. So actually sine of 110, right, because this is the positive part of the y-axis. So sine of 110 is simply going to be equal to sine of 70. How to get the angles that we're talking about for the triangles, and that's simply by adding or subtracting from 180 or adding and subtracting from 360. And then you understand that the cosine is always going to be this part of the triangle and the sine is always going to be that part of the triangle. That's what's going to tell you whether you make it plus or minus. End of story. Total end of story. There's nothing else to worry about. Once you understand these two things that we just said, it's really not that bad. It really isn't. There is really nothing very mysterious about this. Let's say we have an angle of, I don't know, 230. Okay? That means we're going to go past 180, right? But we're not going to go past 270. Just putting all the major points in here, right? So we're going to be in the 1, 2, third quadrant. Okay, they go backwards, counterclockwise. So anyway, 230 is going to be what angle to its x-axis? Well, how far did we go past 180? Or how, 230 minus 180, which is just 50. So that means this angle here is going to be an angle of 50. Right? So that means if I say something like, what is the sine, let's say, of 230? I first think, okay, what angle am I talking about? Well, like I just said, I'm talking about the angle 50. So I know it's going to be the same number as sine of 50 because it's the same triangle. It's just in a different place. And now all we have to do is figure out, is it going to be positive or negative? Well, sine is the y part of a triangle. So what is y over here? It's going to be negative. So sine of 230 is going to be negative sine of 50. What about cosine? Cosine of 230. Well, again, we know already what the reference angle is. That's what we call the angle to the x-axis, okay? I try to avoid all the fancy words because it's just confusing, but this is a good one. It's the reference angle. Reference angle. That's the first thing, the only thing you should really be worrying about is the reference angle, the angle to the x-axis. So it's going to be 50. So we're talking about this triangle here. Now all we have to do is figure out, is it positive or negative? Well, cosine is the x side of the triangle, so it's going to be negative. End of story. One more. Let's go into the fourth quadrant. Right? How about we go back to our favorite example, 290. So let's say, what we're saying is that this whole thing here all the way around is 290. And remember, by our definition of an angle, that just means how far is it from the x-axis, which is 360, okay? Which is also 0, but when we're going this way, we want to think of how far are we from 360. So if we go 290 around, well, the easiest way to do it is really just go 360 minus 290, and that's 70, right? You can do it in your head probably. Just 290 plus 70 is 360. Anyway, so this angle here is going to be 70. All right. So now what is cosine of 290 going to mean? Well, it's going to be the same numerical value as the cosine of its reference angle, which is the 70 that we're actually talking about. And then we just have to think about cosine is this side of the triangle, the x side. What does that look like? Is that the positive side or the negative side of the x-axis? It's the positive side, so it's going to be positive. It's just going to be the same thing as the cosine of 70. What about the sine of 290? Well, the sine of 290 is simply going to be the exact same triangle, so we again know it's the reference angle 70. And then we just think, hey, this is the y side of the triangle. So does this y look like it's in the positive part of the y or the negative? Well, it's in the negative. All right? That's it. That whole topic is actually now taken care of. So sometimes in school, or quite often, they teach you something about like all students take calculus or something, which is supposed to represent like here all the things are positive, and here sine, and here tangent, and here cosine is positive. And then people memorize this and don't understand what's going on, and it's just extremely confusing. It really isn't that hard. All you have to do is understand where we're getting these reference angles from, the ones to the x-axis. And then you just have to understand that the cosine is the x side and the sine is the y side. And I mean, everybody knows that this is where the x-axis is positive, and that's where the x-axis is negative. So cosine is going to be negative over here in these two guys. And sine is the y-axis, so sine is going to be positive up here with the positive y-axis and negative down here. Don't memorize that. All you have to understand is that the cosine is the x part and the sine is the y part. That is the key to the whole unit circle. Do not memorize any of this other stuff. Of course, there's tan. Now, once you've understood this, tan is really also just very simple, one tiny step further, which is you just have to remember that tan, one of the ways to write tan is that it's sine divided by cosine. Hopefully you know that. If not, you can look at the other video that explains that. All you have to do to figure out if tan is positive or negative is think about sine and cosine. Over here, sine is positive, cosine is positive. Well, what does that mean? That means tan in the first quadrant is going to be positive because they're both positive. Over here, we have a negative cosine and a positive sine, and so then if you divide the one by the other, one of them's negative, you're going to get a negative. Down in the third quadrant for tan, sine over cosine, well, here sine is negative and cosine is negative, and you divide two negatives, you get a positive. And then over here, cosine is positive and sine is negative, so you have one negative, and that, of course, gives you a negative again. Again, you could memorize all students take calculus, but I really don't think that helps. It's really more useful to remember that the x side is cosine, the y side is sine. And of course, after a while, you do it like 10 times and you just know it. Oh yeah, tan is going to be positive when either both are positive or both negative. Okay? End of story.